Okay, so we're going to talk about using a simulation to find probability. So the situation says Strauss Market is having a contest. They give a puzzle piece to each customer at checkout. The customer collects all 10 different puzzle pieces, gets $100 in store credit. So we're going to use a table of random numbers so that we can model the situation to estimate how many times a customer would have to shop to collect all 10 puzzle pieces. Because we've all done the Monopoly games at McDonald's where we know that we have to go through a lot of different times to get the different pieces that we're looking for. Okay, so this is just a simulation or a created example to show us how many times we'd have to go to the store and shop. So now I can start anywhere, and what I'm looking for is I'm going to look for 1 through 10. Okay, so I'm going to be looking to find 1 through 10. So I'm going to start right here, and I'm going to go right to left. Okay, so I'm going to highlight any number that is I'm going to highlight the numbers as I come to them 1 through 10, because I want to get each of these. So I got a 3, I got a 1, 9, 4. Now, I don't highlight this one because I already have one. I already have one. Do I have an 8? Nope, I don't have an 8. Okay, do I have a 5? So I'm just going to keep going. I don't have a 5. Do I have a 7? Nope, so I highlight my 7. Now I have a 4, I have a 5, I have a 7, I have a 7, I have a 9. So what am I looking for? Here's a 0. I don't have that one yet. So let's take a look. Let's just stop for a second. At this point, I have 1, 3, 4, 5, 7, 8, 9, and I have 0. So I'm looking for a 2. Now I have 1, 2, 3, 4, 5, and 6. I'm looking for a 6. Okay? So I need to keep going through to determine when I will find my 2 and my 6. So I keep looking, and I'm looking, I'm looking, I'm looking. I still don't see a 2. Keep looking. Here's a 2. That's the first 2 I've come to. And a 6. So now, if I wanted to look, I had to go to that store how many times? Well, each of these has 1, 2, 3, 4, 5, 6, 7, 8 shopping trips. So 8 times 4 is 32, 33, 34. So if I counted each one of these numbers, I would have 34 numbers, right? So I had to go through 34 numbers to get all 10 puzzle pieces. Now, that's one time. Now, what if I started at the other end? Okay, so let's erase. Let's figure this out. What if I start and I go from this point up? Okay, so from this point up, I want to see. I've got 2, 9, 8, 0. I already have an 8. I already have a 9. Here's a 6, a 3, a 5. I have a 9. I have an 8. Okay, so let's see again. Let me stop for a second. See what I have. I have 2, 3, 5, 6, 8, 9, and 0, right? So I need a 1, 2, 3, I need a 4, 5, 6, and I need a 7. So I need a 1, a 4, and a 7, okay? So let's go back over here. I'm going back up. I'm going to go back. There's a 7, okay? I can mark that one out. I need a 1 and a 4. Keep going, keep going. Here's a 1. Keep going, keep going. Keep going, keep going. There's the first time I've gotten a 4. That's going from the bottom up, from the right side over. So let's count here. How many shopping trips did I have to go through? Well, if I have 1, 2, 3, 4, 5, 6, and I have 1, 2, 3, 4, 5 columns of 6, that means it took me 30 numbers or trips. Okay, I need to fix this here. To store to get all 10 puzzle pieces. 14. pieces. Okay, we still use our language arts. So we can see how this is different depending on how we view the simulation. But this is an example of how we use our simulation to answer our questions on probability. So again, the first way that I did it, it took me 34 times to get my 10, or the second time it only took 30 times to get my 10. I could take an average of those two, and on average between these two options, it could take me 32 times, because that's if I added the two together and divided by 2. But we're going to talk about this and do some examples in class.